Good afternoon, everyone. Thank you for joining this second webinar on domain-specific search engine. Gael will guide you through this technical discussion today. So, since everyone is muted, should you have any question, please feel free to type them in the question pane. I'll be gathering them and sharing them at the end of the session. And that's it for me there. Gael, the floor is yours.
Thank you, Samir. So just maybe a quick word on this series of webinars that we are organizing. So we are trying to share a bit what we've learned at Unit8 through some of our projects. Some of the talks are more technical like today, and some are a bit more business oriented. So we have a few of them still coming in next week, so have a look if there are topics you're interested in. So today, we want to discuss a domain-specific search engine. So this is to oppose them as something that would be an all-purpose search engine like Google, indexing the whole web, or maybe some enterprise search tools that would index all the documents of a company. Here, in a domain-specific search engine, we have a bit more context about what people are looking for, and we can use that to tailor the search engine. And that's what we will go through today. Maybe a quick word on myself. So I'm a data scientist at Unit8. I worked on different projects, one of them being a search engine where we indexed some products a company was selling, so employees could find more rapidly what they were looking for. With that search engine, we've added a few labels that were generated with some of our machine learning algorithm. And yeah, this will be kind of the basis of the talk today. Before that, I was data scientist at Swisscom working on big data and trying to detect issues with the mobile network in real time. So enough about me. Let's start on the topic of today. And first, I want to start with a quick reminder that great search engines are everywhere, even if we're not talking about them a lot anymore. Maybe we're more talking about machine learning these days. They are still a key part of many of the products we use every day. So I don't have to present Google, but I think what this image shows is that the power of a search engine is that a single text form can allow you to search across millions of documents. So just by typing a few words, you can find what you're looking for. And that's kind of the attraction of search engines. We also have search engines on website, e-commerce website like Amazon. So it's fairly easy to find the one or two products you're looking for across the millions that they have. And here, contrary to Google, we have already a bit more context about what people come for. So they're looking typically to buy a product. And also the data that we have is a bit more structured. So we can kind of use that context to make a search engine a bit more custom and provide more relevant results. Some other examples are, for example, Uber Eats, where you can easily find a restaurant. So here you don't have millions of restaurants, maybe hundreds or thousands in the largest cities. But still, there's a lot of effort from Uber to try to give you the most relevant results. And if you look at their blog post, they publish a few explaining how much effort they put into trying to give you the more relevant results. Because if you don't find what you're looking for in the first few, you're likely not going to order from them. So again, like a key part of the application. And so we've seen some examples from kind of the web companies, but when we look at tools that we have in some of the organizations, sometimes they are not as great as the ones I've just showed. And maybe they look a bit more like something like this that you may recognize in your work, or you've seen people using that. And this is like a search engine where you can search for, I don't know, change requests that could be products, tickets, or anything. And to be honest, okay, they probably work. You can find the result you want, but they have a few like shortcomings. The first one is that they are built on top of SQL databases, which are not really optimized to provide text search. So typically when you're typing and then launching the query, it's going to take a few seconds, sometimes a bit more, to provide you with the results. In addition to that, they are very sensitive to typos. So if you make any mistake in the name here, you're likely not going to find the result and you'll have to enter again your search term. And sometimes you have some tricky things you need to know, like, okay, you need to put stars around the word. Otherwise, it's not going to pick up if that word appears in the middle of the text. Additionally, you have some filters that are probably a bit too complicated for what they do, but they don't help either having a great experience. Otherwise, sometimes we also see this kind of search engine. So this one is a bit easier to use. And that's a typical search engine that you would see to search across all the documents of a given company. And we can see here it provides okay results, but for example, the second one doesn't even contain the second word we are looking for. And having used this in a few companies, I think most of the time the results are not always super well tuned, and it can be sometimes hard to find what we want. So this is often the experience in companies, and I think companies should care a bit more about this, because search is really kind of an easy interface to be able to find data among a large corpus of documents. And in our fast evolving world, we want to be able to find answers more and more quickly. So I can think about you have to resolve a customer problem, so you want to look at the history of that specific customer, or you want to find other similar problems that were already resolved by some of your colleagues. And this is a process where having a good search engine can really benefit a lot. Our experience with search engine is that we developed one and we got a lot of positive feedback, even though search engines are nothing magic, even though some of our users, they called it magic search. We don't do anything crazy, but just having a good search engine, people care about that, and that makes their jobs much easier. And then there are many processes where the companies can benefit from that. So you want to be able to find the correct products, so you need to find it according to some criteria or keywords. You want to find the relevant people in your organization. So all of these things can benefit from having a good specialized search engine. Finally, just a word that has become fairly easy to customize and deploy these systems. So most companies have systems where they have data pipelines or sometimes even data lake, which makes access to the information easier. So it becomes easy to gather the right information. And then deployment of the search engine has become easier and easier with Docker, or sometimes if you're lucky Kubernetes, you can easily run these tools. So enough about why you should care. I think let's jump into the topic of today. And first, I want to ask a question: and why and how are domain-specific search engine different? Sometimes they're also called topical search engine if you look on the web, just for the side note. And for that, I want to start with an example. So Google has this product called dataset search. And we can ask ourselves, so why does it exist, and why can't I just use Google to find the right datasets that I want? And you can find the datasets on Google, but if we look at the result produced by the search engine, we will see a few differences that will make the experience much better and easier. So here I typed some random keywords suggested by the tool, and we can see that directly I have a list of very relevant data sets, whereas if I would have typed similar queries on Google, it would probably be hidden among other search results, and it would be a bit harder to find the right results. So this is the first thing. Also, what we can see is that they clearly label from who the data is coming, and they make some effort to try to select the most relevant and important sources. So that's the first element, like curating the search result. The second element is also they've condensed the information to what really matters, so I can easily see what time period this cover, having the quick and short description. And this has two effects. One, it's when you index the data, you have much more relevant text to index. And two, when you are assessing the search result, you can more easily find if it's the relevant data set or not, or if you should have a look at the second result. So these are some of the things that having some specific domain allows you to do, because you have context about what people are searching for and what they want to be able to get. And in general, I think we can classify 3 key areas where that we can leverage with domain-specific search engines. And the 3 areas are the following. First, curation of content is pretty important, so we can remove a lot of extra information that is not relevant for the specific use case that we have in mind. We can also make sure to only index the most important fields that contains the key keywords that we have. That would be aspect number 1. Aspect number 2 is that we can add key contextual data. So suppose you're building some search engine to find people in your organization. You have like the different people, but you can augment these documents with a lot of extra information that maybe are in some other databases. Like you can know the role of these people, which department they work with, maybe all their user IDs, their colleagues. And then if somebody is searching for people in a given role, then you can show up result for Jane Doe, for example. So that's something fairly easy to do, and that brings a lot of value. In addition to using existing data that you may have, you can also add some data that you generate yourself. So imagine if you have some bestseller items, you can look at the sales figure and label as bestseller maybe the product that you're selling the most. And if people are searching for bestseller, then they would be able to find them easily. Or if your data contain images, you can use some fancy machine learning algorithm to kind of create captions for these images and index that as well. So this is something very useful to do. And finally, the third aspect I will focus on today is how you can tune your queries and search results. And this is mostly 2 things. First, make sure you're indexing the data properly. We'll see what that entails in the next slides. And then tune the search results so that they are providing relevant results. So let's start on the a bit more technical part, and let's see how we can do this with Elasticsearch. So I'll do a quick slide on Elasticsearch just for the one that may not know what it is, to give you a bit of context. So Elasticsearch is a document-based database. So as opposed to traditional SQL databases that would have rows of data, here we are indexing whole documents. It's used for search, but also analytics use cases. And one of the key things, contrarily to a lot of SQL engine, is that it's distributed and scalable. So as your user base grow, you can add more machines, or as your data grow, you can add more machines to handle all the work that you have. And finally, it also comes with a lot of tools to easily ingest data from many existing databases or systems that you may have in your company. So you have Biggs and Logstash that are things that will help you get data into Elasticsearch. And also, it's one of the most popular search engine, open source search engine. And that's why we're talking about it today. During this talk, if I had a bit more time, I would enter a bit more into how to set up Elasticsearch and what are the basic way to index data and query. Today, I want to focus a bit more on how you can really customize your search results. So I'll try to introduce concept as much as possible. But know that we have some notebook here where we introduce a lot of the basic concepts. So if you have any question after the talk or anything doubts, you can have a look here at how we can do this. Also, it's a good reference to try some of the techniques that I will show. And in this notebook, we go from having a data set to having some mini search engine. So have a look if you're interested. Maybe that can help you after the fact. So the first thing to provide good search result is first to understand at least the general lines of how a search engine is working. And from a high-level point of view, the search engine does three things. First, it's going to take some documents, and it's going to split the sentences in these documents into words. And that's the part that we call tokenizers, so taking the sentence and turning them into words. And then in order to have a fast search result, we want to index these words in the proper way. So this is indexing. And once we have our document indexed, we can then finally have user coming in with queries, and we can return documents ranked in a given order of having the first most relevant results appearing first. And this is the ranking part. So we'll see how we can use each of these different parts and tune it to use the context that we have. So if we put these different parts into like some kind of picture, we can see our documents that are tokenized, so split into words. Then we have an indexer that will index the document into our storage, which is the index. And then on the user side, so we have a user coming with a query that would similarly be split into words. And then we would query the index and return the results. So let's start with how tokenizers are working and how we can adapt them to our needs. So tokenizers are also called analyzer in Elasticsearch, and this is so because they do a couple more things that just the tokenizers do. So what they do is they have three steps. The first step is some kind of pre-processing that allows you to maybe remove some characters that you don't want, remove some HTML banners, for example. Then you have the tokenizer itself that's going to take what comes after the pre-processing and split that into words. And then you have a filter that will allow you to either remove some words or add some words, as we'll see later on. And the way to express these things in Elasticsearch is when you create your table, or in Elasticsearch is called an index, you can give a document that will define how that index looks like. And the most important things are the fields that are contained in that in your index. So here we have a simple example with a product name that has description, categories, tools, and so on. And then what you can give some custom analyzer. So by default, it has some analyzer that is tuned for English, but you can very easily define your own and then customize it. And the way to do this is you can define here my analyzer that is a custom one. And we can see here that as a pre-processing step, we would remove all the HTML tags. Then we would use a standard tokenizer, which standard is typically for English language. And then we would lowercase all the words, and that would be the post-processing part. And so we can see it's fairly easy to define our own custom ones. And in the next slides, we'll see a few examples of what we can do with that. So the tip number one is typically you have some fields that are fairly important to the search. So it could be the title of your documents, like if you have news articles, could be the name of the person in your organization. And so you want to make sure you're customizing your analyzer and making the analyzer relevant for these fields. This can be very important if you have some IDs which have different logic than some text in English. So that's something important to do. Here, I will just show you a bit what is the default one, and then we'll see how we can modify that one a bit. So imagine I have some input fields that have or still some HTML banners inside. So we don't think that is really relevant to the search results. So what we do is we want to remove them. And this is one of these char filter, the HTML strip that we've seen before. So just to remove that because it's not useful. Then we have the standard tokenizer that is going to take that sentence and split it into words. So that's all it does, like splitting by white spaces or some special characters. We can see it remove the special characters. Then we're lowercasing because we don't think the case is important. Typically also remove stop words, which has all these very common English words like the, and, or, that are not very relevant to any search. And finally, snowball is a way to take the root of given words. So for example, lazy turns into lazy with an I, and so that would match both lazy and laziness. So you have a bit more flexibility appearing by doing that. So here it's something you may want to customize if you have data in different languages or maybe multiple languages in one field. So German is a tricky example with composed words. So you may want to add a step that will split this word like ballet dancer into two. Or you have IDs that could contain some special character that will be removed at this step if you don't do anything. Or maybe sometimes you care about case sensitivity. So a lot of things that are really context dependent, but that's where you're going to do the work. It's through this analyzer. Here are a few things that we've seen in real life, just to give you a bit more concrete examples. There are many things you can do, but then it will be up to you to find the solutions to these things. I think you'll have the tools to do that. One thing that we've seen is that we had some ID with coming from some Windows system, and they had this M dash instead of a typical dash. So if you would type the ID with the dash in the search engine, it would not show up because of that. So one thing you can do is you can kind of standardize this character and do a char filter that is replacing that special character by the standard dash. So as you can see, it's fairly easy to add a step to do this. And then you can see that your ID field has this analyzer now, and you shouldn't have this issue anymore. I've talked about language issues. So this composed words is a pretty tricky thing in German. In French, you have L apostrophe also, which can be an issue in some cases. So here's where you want to maybe use the language tokenizer. There are a few available, or maybe customize it yourself. Another thing that you can do in this analyzer is include some synonym, and that's very useful in some cases where something can have different names. So one example here would be a synonym for region. So you could have a region field that maybe contain Europe encoded as Europe, or EU, or EUR, depending on who generated the document. And you want to make sure the search results are accessible regardless if you type Europe or EU. And here you can give a filter. So that's a first processing step after you splitted your word. And what that filter will do is will repress any occurrence of this word by the 3 words. So the document will match any of the 3 words here. And that's something very useful when you have, for example, abbreviations for departments that have different names in different languages. Maybe you have hierarchy of departments, so you could include the hierarchy here. And there are many use cases where this is something that we very useful, and we've used it quite a lot in our case. Finally, there are many things you can do here, and a lot really depends on your context. And so if you're interested, I would point you to that article where you'll be able to find a lot of the things that you can do, and maybe some of the problems you'll be able to solve. Now I want to talk a bit more about customizing the ranking part of the search engine. So the first thing is maybe understand a bit how the ranking is working. And for that, I will show you this kind of crazy looking equation, even though we'll see it's fairly simple once you break it down. So what this equation does is how each of the documents, so D here, are scored for a given query. And we can see 2 parts. So one part that is kind of general terms that apply to the whole query and documents. And then a part here that will apply to each word of our query. So we've splitted our sentence into words with the tokenizer. And now we're going to use that to rank, to score each of the words and sum that up to give a score. And here, so there are different aspects. The first one is what is called the true frequency, which counts how many times a given word appears in the document. So if a word appears many times, then the document will rank higher. That's very intuitive. We have this IDF, which is this inverse document frequency. So that's going to look at how often a word appears in all documents. So if a word only appears in one document, this will be very large because it's a very rare word. So matching this rare word is quite uncommon. So this contributes a lot to the score. And then you have a boost that you can apply to different fields of your data. So if you have a title or subtitle, maybe you want to boost it because it will be more relevant than the description. And finally, you have a normalization that will penalize a bit some of the fields if they are very long, because if they are very long, they are more likely to have many times a given word or to have the word at all. So we want to penalize a bit these long documents. And finally, on the other side of the equation, we have here this score term that computes how many of all the words that we have in our search are matched. So if you're matching all the words, it will be higher. If you're matching only one of the words, this will be lower. And finally, this term is not very helpful. It's just a normalization. So all the queries that you'll make will have kind of similar scores. So you can kind of compare the different queries together. And to rephrase what this means is that documents containing all the search terms are good. Matches on rare words are better than common words. Also, long documents are not as good as short ones if they match the same amount of words. And finally, documents which mention the search term many times are good. So this is this true frequency that we've seen. So now that we understand this, what can we do? So the first thing and the easiest thing is to boost some of the most relevant fields. So assume that we have a search engine for a product. Probably we want to boost the product name because this is the most likely to contain the most important words. So if you're looking for a speaker, the product name would generally contain speaker, whereas the description could contain also some other words that are maybe not always relevant. Similarly, for categories, you may want to boost it as well, but maybe a bit less. So what you can do is when you're creating your index, you can assign this boost coefficient for the different fields, and then you'll have this part here, depending on the field where the word appears, boost that given word and increase the score. So that's a fairly easy tool to use. Another thing that we've used a lot is that I talked a lot about matching words, but I haven't talked about matching sentences. And sometimes what may happen is that you're searching for a phrase like event sourcing using Kafka, and the first document that would appear would be that one, like Kafka had to configure. So maybe that one inside the document is matching Medital Kafka or event sourcing. But in third place here, you have a document that contains the exact phrase that I'm searching for. And so by default, this wouldn't be kind of boosted, or this wouldn't appear first out of the box. And we may want to have this one first because it's matching exactly what we're looking for. So a way to do this is when you're querying Elasticsearch. So here is an example of an Elasticsearch query. I will skip a bit about how this works exactly because I think you will find plenty of tutorials to understand that. But what you should focus on is this match, which is that logic that we've seen here. And then what you can also do is use that match phrase that will look for documents that have the exact sentence. And here, this should is going to combine the score of the two. And if one has a match phrase, it will have a non-zero score here and thus appear higher. And that's how we can make results such as these appear higher in the ranking. Finally, the last tips that was very helpful to us that I will give here is using what is called a function score. So here, this equation gives us a score for all the documents, but we may want to tweak that score a bit depending on a few factors. So imagine that you have a document that is, I don't know, a product that is archived, and maybe you want to penalize this product appearing high because it's an archive one, so it's less likely to be relevant today for a salesperson, for example. So what you're going to do is you're going to add another term to the document that will be based on if that product is archived or not. And you can do that using the function score. So here we have the query, similarly to the one we've seen in the previous slide with the match. And what you're going to do, you're going to multiply some score, and here the score is the number of likes of a given document. So maybe you want to favor documents with more likes. And so you're going to just kind of boost that score with this number of likes that it has. And that's something fairly useful. So for example, you want to promote popular items through the likes, or maybe you have some fancy machine learning algorithm predicting which products are popular, and you can also do that through this tool. And combining the different tips that I've shown you, you can kind of build a query that will look like this. So I will leave you the exercise to write that query in Elasticsearch language, but you can combine the different aspects and have this field boost, combining this match phrase with the match that we have here. And then we can multiply by various constraints that we have. So that's something that an architecture that we've used and that proved to work pretty well in our case. So I'm already 33, so I will go a bit quicker on that step. There are lots of things we can tune. So that's a risk when we change them to break some things that are working. And one useful tool that Elastic is providing is the ranking evaluation. And the ranking evaluation, what it allows you to do is to combine a list of queries as well as search results that you would like to see appearing and in which order you want them to appear. And what you can do is you can change your logic. So maybe tune these boost fields here, and then compute the overall score on this whole database of queries and results that you have, and make sure you are not breaking something important. There is more information here if that's something that is interesting, but that's a great tool to make sure you're not breaking some of the things that were working in the past. Finally, I'll take a couple more minutes to just talk about what's next in the world of search engine. There are lots of things going on in the NLP world, so natural language processing, and I think they will have some impact on search engines. So I just want to quickly go through some of the areas I think will benefit from that. The first thing is entity-based search. So we've talked a lot about words, but sometimes words have some meaning. So we have an example here where we have Johannes. But if I can understand that Johannes is actually Johannes Müller through some, I don't know, machine learning algorithm or through some manual labeling, then I can make this document more relevant by indexing as well his last name. So now if somebody is typing Müller, this document will appear. So Elastic already supports that notation that we see here. And the NLP algorithms that are being developed and progressing very rapidly, maybe they will enable to label that kind of data for very cheap or very easy. And then we can benefit, that can benefit your search. Another thing this can also help to do is you can change your interface to have the user kind of help you select what he's looking for. So here is one example where somebody is typing revenue, and I can suggest different type of revenue. And here the user can select, for example, if he's interested into the billing metric or the CRM metric. And if I know which documents are referencing which ones, I will be able to provide much more relevant results. Finally, a second stream, I think that is very promising are language models. So language models are trained on gigabytes of data, and they're trained to, for example, predict missing words. And through that exercise, they are gaining some kind of understanding of the meaning of a phrase. And that's something Google is using already in 1 out of 10 queries. So we have one example here where can you get medicine for someone pharmacy before was returning results, getting a prescription filled, which is not what we want. And after that, can a patient have a friend or family member pick up a description? So that's something now that is giving you the right results. And that's something that we can already start doing today if we want to. And the way you can do this would be with an architecture similar to this. So Elasticsearch released recently some way to compare documents. So you can turn your documents into vectors that are that is the get this dense vector that is kind of representing the meaning of the phrase, and then you're going to be able to match it against all the title of your documents. And that's how you can really not just look for words, but look for meaning, because these two would have probably would be very close in this vector space that you generated with the language model. And there are many things I could talk about because I think machine learning opens a lot of areas. But I will stick to that today, and you can find a few more examples here in the slides that I will send after the talk. So to conclude, setting up and configuring, I think, has become relatively easy, and I hope I helped you a bit to overcome some of the obstacles you might face. Second, context is key, so make sure you use your expertise to select documents, to get the right data, and then tune the relevance of your search results. And then another point is that a good search engine can really have some real practical impacts. Maybe that's not as easy as selling AI, but in practice, if you have somebody saving 18 minutes several times a day, times hundreds of people, it can quickly have a big impact on some processes in your company. And yeah, just a word, follow up what's happening in the NXP space. It's very interesting, and I think we'll see the fruits very shortly. So I will stop to that with 39, so a bit over time, but I hope that was worth the extra time. And I don't know, I think we'll open the floor to questions. Samir, are you here still?
Yes, thanks, Gael. Yeah, we slightly overshot the deadline, but I'm going to share a couple questions now. But if you have others, please feel free to raise your hand and we'll pass you the mic. So one of the first questions we have is more about analyzers. So if you were to have documents in different languages in your database, would you be able to search all of these languages in just one query, or would you need to input the same query in each of the different language?
So depends on which combination of languages you have. So if they're fairly close, maybe the same analyzer would work for both. If they are different, what you can do, you can either try to split these sentences into the different documents. So maybe you can infer if it's a field that is in Italian or English, and then split that into two different fields that you would then index differently. And that's one tool that you could do. So have two analyzer and index the fields differently for the two languages. Or sometimes if you want to keep all in the same field, you can try to run two analyzer on the same field and then try to maybe have a combination of both when you're doing the query. And maybe that's kind of average out, or you would also, if you have like English and German, maybe you can average the two results from the analyzer, and maybe that's good enough. I think it really depends on the case and the documents that you have, and something to play with a bit what works best for the use case or for the documents that you have. So I hope that this answers the question.
Thank you. And another question still on analyzers and the predefined and synonyms. Do you know if there are any lists of predefined synonyms, or do you need to set them up manually?
So you can do different things here. So in the example, I've shown the list explicitly in the indexing. What you can do is you can reference some text file or CSV files that you have somewhere. So if you have already an existing CSV, you can just link to that, and then Elasticsearch would do the mapping automatically in your analyzers. You don't have to fill in all these documents, all these equivalents manually. So that's one thing you can do, and maybe the question is about if there exists some list of synonym somewhere. So I know for Switzerland, for example, the admin website has some lexicon that have different terms in French and German. And that's something that can be pretty helpful if you want to, for example, label the different departments in different languages. So you can reuse that, and I'm sure you can find similar resources online for regions, or maybe hierarchies or different ontologies that already exist.
Thanks. And looking at the time, maybe one last question, more generic question. What were some of the main challenges you faced when developing the search engine during your project?
Yeah, that's a good question. So I think the first challenge is always having the right data and in a right format. So cleaning up the data that is not needed. So we had, for example, some artifacts from other systems that were adding some kind of prefixing all the fields with some random words. So we needed to remove that. And then one issue that we faced in that we came up with like some kind of query for the search results, but at first, like the UI was a bit primitive, so most of the feedbacks we got was on the UI instead of really the search results. And so until we fixed that, we were getting more feedback from the UI that what we really cared about, which were the search results themselves. So that's something that we had to deal with, and I think maybe that surprisingly was one of the challenges that we faced.
Thanks. So I'm not seeing any further questions. So perhaps you could give us a 10-15 seconds teaser on the next webinar.
Yeah, so I think I have a slide. So it's next week at the same time. And what Radu and Bianca are going to talk about is entity resolution. So that's a fairly important concept if you're a big company that wants, for example, to have one entity for each of the customers. So if you've acquired other companies, sometimes it's really hard to reconcile the different data sets. And so that's a fairly important problem. And also, I think technically, there are a few challenges on how to solve that, because if you were to compare all the records one by one, then you would have n records to match with n records. And if you start having millions of records, that's million squared. So I think they'll explain how you can get around that complexity limitation.
Awesome, thank you.
Yeah,
so
I think it's
yes, we're just sharp on time. So thanks everyone for joining us today. We'll be sharing a video very soon after this session, and feel free to come back to it or share it with other people if they might be interested. I wish you all a good afternoon and see you next week.
We will send the slide with some useful links as well, so
yes,
you can refer to that. Have a good week, and thanks for joining.